It's time for the Science Cafe!
Learn about the latest technological innovations today.
And you don't have to pay.
Expert panels with advanced degrees are sure to satisfy your curiosity.
Since we mention it's free.
And if you think you'll find a better time than this, then come on down and test your hypothesis. Cause you're gonna learn a lot if you wanna stay down at the Science Cafe.
Hello, good evening, and welcome to Science Cafe. Hello. So my name is Dan Marchak. I'm one of the organizers here. Scott's also another organizer. Rick Irving and Steve Ruddock have helped with all of this. But before we start, I want to find out how many people have not been to a Science Cafe before. Wow. So most of you have. That's great. So what we want to do is just bring panels of experts together with the public and have a conversation and try and move the meter that way. Tonight we're here to talk about SETI and space aliens and discovering life and science around that, which is really kind of cool. So the way it works is I'm going to introduce the panel just briefly and let them introduce themselves in some detail. I'll ask them to make an opening statement and sort of describe their interest in space and aliens, and then we'll throw it open to you. So without further ado, I'll introduce our two panelists, Skip Crilly, who works at the Green Bank Observatory in West Virginia, so we're very lucky to have him here. And Johnny, I'm not sure how to say your last name, Gelsomini.
So I'm a high school physics teacher at Lawrence High School. I teach physics and robotics, and I've taught a couple years of astronomy there also. I graduated from UMass Lowell in the Physics and Applied Physics Department in 2013. And while I was there in my undergrad, I did a lot of stuff mainly on acoustics, but I took a few astrophysics classes with Professor Silas Laycock, who worked at the Smithsonian. That's my background on the subject.
Yeah, my name is Skip Crilly, and I work at the Green Bank Observatory in West Virginia, but I live in Dunbarton. So I commute. I have a 700-mile commute to go down there. And I've been working there for 4 years, so I've done it 45 times. Because I'm down there for a week, and then I drive back after a week. And I do that about once every month. Now I do it about every 2 months. And my job there is I'm responsible for one of the telescopes. It's the educational telescope, which if you ever get a chance, if you're ever in the area of West Virginia, stop by. You get a fantastic tour. And if you have students, you can arrange to have them use the telescope, the telescope that I'm responsible for. So I'm an electrical engineer. I grew up in the Philippine Islands. My parents were very adventurous. When I was a baby, we moved our family to Mindanao, the southernmost island, and they managed a farm that made abaca, the thing that you make manila rope out of. And I, over the years, just very fascinated with astronomy and radio telescopes particularly, and I built my first radio telescope in downtown Manila. Wanted to be in physics, wanted to be in astronomy. Those were my goals in college, but I couldn't get work doing it, but pretty much. It's a tough time. So I went into electrical engineering, spent careers in electrical engineering at Hewlett-Packard and building equipment for the communications industry. And then founded a few wireless companies, co-founded a few wireless companies. Now I've been retired for 2 years. I was working for another company in Manchester, but I decided to retire. And 4 years ago, I sent my resume down there to Green Bank, and they accepted it. They said, fine, because I said I was a volunteer. That worked. But the icing on the cake was that when they gave me the job, they also said, we have 4 working telescopes here, and one of them is your responsibility to work on. So I was a kid in a candy store, and I got to fix a bunch of things that were needed improving for the students. So I spent 2 years doing that, and then I spent the last 2 years using it for SETI. And I've done a lot of SETI projects over the years, so it was natural for me to bring my computer that I programmed to Green Bank and put it on the 40-foot telescope while I was there. So for the week that I'm there, I run the telescope and search the sky for pulses. And I've been doing that on my farm with telescopes in Dunbarton also, and also in other past projects. So maybe if I guess I should just go through these slides quickly if I can, and I'll just, hopefully, the purpose of this is to just get kind of started with some ideas about how SETI works, and it might help to bring some questions. We're doing a project that's a little bit different than what has been done in the past, as far as I know. I have a lot of friends in the SETI community, and I ask them if somebody's tried this. And it doesn't seem that they have. It's to use two telescopes very far apart and listen on the same frequency at the same time for long periods of time on a wide frequency range with narrow bandwidths. And it doesn't seem like it's been done much, but sometimes sporadically when they're trying to follow up on something that they think they're seeing on one of the telescopes. So let me just go through these. I'll do it pretty quickly. The first one is, the first page is that generally large radio telescopes are used for SETI. The telescope that's the picture here that I took of the 100-meter Green Bank telescope. This is the world's largest telescope. It's a radio telescope, but it's larger than optical telescopes. It's in West Virginia. This is the world's largest moving land object. It's the world's highest gain antenna. It goes to 115 gigahertz, if you're familiar with frequencies, from 60 megahertz to 115 gigahertz. And it has cooled amplifiers up there at the top. So you may have heard of SETI at home. There's a project that's been going on. It's the world's largest computing project. It's been going on for a long time. It's the mid-90s, I think, was when it started. In Berkeley, they collect the data from the Green Bank telescope and also from the Arecibo telescope, and they compile that into packets that go out to people's homes. Now, the picture on the left is I took in the lobby of the Department of Astronomy at UC Berkeley. This is a monitor that's located next to the elevators that they keep track of the packets that are flowing for SETI at home. And this is actually a moving lines, and you could see little dots, and they represent the packets that are flowing between the telescopes and then also to people's homes for their screensavers to search for signals. Now, this project at UC Berkeley is one of two major projects. The other one's called Breakthrough Listen. And this was started a few years ago with a very large donation from a billionaire venture capitalist named Uri Milner for $100 million. $25 million went to Green Bank. That $25 million gives Green Bank they can use the 100-meter telescope for about 20 to 25% of the time to search for signals. And then those signals are processed by the Breakthrough Listen team. Okay, so I'm a member of the collaborators team on that. So I call in on the meetings and things, and they've given me time on this telescope, this large telescope, to search for some things that are interesting. The biggest problem in SETI is interference, and it's been almost insurmountable for so long that it's almost a showstopper for almost any wow signal. Everyone who's done SETI has come across wow signals. I've come across lots of them. And when I see them, I go, yeah, wow, but it could also be an unknown satellite. So because of the problem with all these devices that produce all these different frequencies, I have been interested in trying to do SETI with two distance-spaced antennas. And that's what we're doing now. So on the next slide, about a year and a half ago, we set up a duplicate system to the one I use in Green Bank on a dish antenna in Colorado, in Haswell, Colorado. It's in the middle of nowhere. This is probably the quietest place. It's in southeastern Colorado, and it's completely surrounded by fields. The nearest town is 5 miles away. It's at the bottom of a meteor crater, so it has a natural RFI filter. And it's fantastic. It's run by a group of amateur radio operators and the Deep Space Exploration Society. So I set up my computer there about a year and a half ago. And then when I go to Green Bank, I bring my computer from home, and we operate these two telescopes together, synchronized with GPS satellites. So the idea is to search for something that's coming into both of these antennas on the same frequency at the same time. And we let the Earth rotate. So we scan the minus 7.6 declination arc. I do that because over the years I've been on my farm searching various declinations, and I tend to see some weird pulses at minus 7.6 along that arc. It also goes through 40 Erdani, which I've seen some strange things there. So we just scan the sky. We run it generally for 20 to 40 hours when we can. They're both difficult places to get to for both the people there. They have to drive 2.5 hours to get to this dish. And I drive, much longer than that. So about 13 if everything works out with the weather. So what are we starting to see? So we've been running this now since last November. And now the very first thing I have to say is that this is not a claim of any detection of signals from extraterrestrials, okay? And these stories you see in the news about, wow, what a fantastic thing. The astronomers have discovered some signal and they can't explain it. Well, I'm jumping up and down for joy when I see that, because I want someone to find something, because I like my life the way it is now. Okay, I'm in this for the journey. Okay, I love building radio telescopes, and I think it would be good for humanity. But I don't claim that any of this is extraterrestrial. It's perhaps one way where we can get a little bit closer to trying things. So we've seen a bunch of pulses that are on the same frequency at the same time, and these are the dots that are on the outside of this. Now, because the antennas are so far apart, they're 1,257 miles apart, and we use Doppler shift, and the bandwidths are very low, 3.7 hertz. We can filter out things that are close. So within 720,000 miles, we filter out satellites, airplanes, things in orbit, local radio frequency interference. So these pulses should be the result of something that's very far away. And we've seen about 16 of these in the small frequency range. Now, we were quite surprised because right up there in the corner at like 22.8, in the left corner, there's a red circle and a yellow triangle. And it turns out two of the pulses that we first saw were in the same pointing direction, within 0.7 of a degree on the sky. Well, this got my attention, but we haven't seen anything yet since then. That was in April and in November of last year. Since then, in 3 times, we haven't seen anything in that same direction in the sky. So that's sort of, somewhat interesting. But the very strange thing about this is that if someone wants to get our attention, they're going to do something to make the signal not look like noise. And the 2 pulses that we got on 2 different times in that same pointing direction, ideally, if someone wanted to tell us, yeah, that's not noise, well, why not do something about the signal that makes it not look like noise? And as it turned out, one of the pulses, one of the ones at Green Bank, had a very close tone. It was only 53 bins. It's about 198 hertz offset. And generally, tones are far apart. They're 2.5 megahertz or so due to noise. So that 198 hertz offset tone has a calculated likelihood of about 3 in 10,000 tries. So on that first one we saw, there was another event that occurred that should happen after we've done this experiment 10,000 times, 3 times. So that kind of gets my attention, and that's what we're doing. We're looking at this in a way of saying, okay, how many of these pulses also have these other pulses called that I call associated pulses? So the idea is that a pulse shows up in the two locations, but then there are also other pulses that are used for detectability, and also to convey the fact that information is being transmitted. If all we saw were tones that appeared at the two locations and there was nothing else in there that looked like information, then I would conclude that there isn't any information that's in the signal. Okay, so that's sort of, it's about trying to rule out noise. I'll finish very quickly. I'll try to just finish this very quickly, but I do talk too much. Is that there are these simultaneous pulses, and there may also be associated pulses associated with the simultaneous pulses. And the idea there is that they may be different at the two sites, because this is the guess associated with the hypothesis, is that extraterrestrial communication to Earth requires that the planet cooperate before decoding can occur. If you guarantee that two locations on the planet immediately state, based on the engineering of the signals, that these signals are different at the two locations, then immediately the engineers conclude it can't be decoded unless you have more receivers. Who knows, 2 may not be enough. Maybe we need 10 or 12 or 1,000. So that's why we're looking for pulses that are simultaneous for the detection purpose, but then different from the standpoint of trying to falsify the hypothesis that the signals are different.
So in working with both Green Banks and Colorado, what about the Allen radio telescope array?
I've used the Allen telescope array. I used it to look for some things that were interference that I was seeing at Green Bank. And that's a possibility, is to get another telescope. In fact, on this slide, I'm trying my best to encourage others to add to this concept of running simultaneous telescopes all over it, as many as possible, synchronized.
I come from maybe a different place on this, because I'm convinced that there are extraterrestrials around, but I don't think they use electromagnetic communication. I don't think they use electromagnetics. They probably use something that's faster than the speed of light. I went to a SETI meeting with Jill Cornell. Do you know that name? She was that's her maiden name, and I don't know her other name. But she was the granddaughter of Ezra Cornell, the founder, and Arecibo, the telescope, and so forth. And I wanted to ask the question then, but I didn't, that if they want to have contact with us, wouldn't they have far greater technology and be able to contact us anytime they want? And if they don't use electromagnetics, then are we going to find them the way you're looking?
There's a couple of parts to that that I'd like to respond to. So, if they don't use electromagnetics, that's possible. But, you then ask the question, what is it that they do communicate with? Hypothetically, could you communicate at faster than light time? That's possible through quantum entanglement and things like that. Even here on Earth, where you're working on supercomputers that work on that same principle. As far as whether or not they would have the ability to communicate with us whenever they wanted, if they were really that more advanced, if you may have a dog or a cat and you can talk to them all you want, but does the dog really understand any more than you calling its name? There's an argument to be made that it doesn't. So even if they do have that technology, that doesn't mean that we're necessarily going to be aware of that.
But there's a lot of evidence that they have visited the Earth. There's a lot of evidence that I don't think it can be totally ruled out.
It can't be ruled out, but it also can't be proven.
I wouldn't even say that. I'd say if you knew all the aspects, it probably could be proven. But you would have to believe somebody. You have to get into certain areas and see things. And I'm not just talking about Area 51 and things like that. But there's an awful lot of things hidden. And the history is old, including ancient history. Weird things that have happened over the years, over the centuries. So I'm convinced that somebody is there, and I would claim I've had communication. And I think it's telepathic, that type of thing. And I think it's certainly faster than the speed of light because you never get anywhere at the speed of light in the universe. And I think we have to look very differently. But I think they're out there. And they're so far advanced that we can't understand where they're coming from in most cases.
Very interesting comment you made about if they were deliberately trying for us to hear. I think that's exactly right. Do you know if anyone on the Earth is broadcasting a signal with the deliberate intention of trying to be heard? And a second question, kind of tangential to another comment you made, is the SETI organization using any kind of distributed processing like, Google's Hadoop program where the millions of home PCs that do nothing all night long, can be used to process that enormous amount of information?
A couple years ago, they broadcasted the Beatles song across the universe as a radio frequency out towards the closest star, just because it was the 40th anniversary of the song coming out. But also one of the first attempts at that was with Carl Sagan, and I think it was Voyager, and they sent out a whole platinum disc, and they're constantly beaming out radio signals. I'm sure SETI is doing a lot on that, so I'm actually going to let you address the rest of that question.
It's called METI, Messaging for Extraterrestrial Intelligence, or Messaging 2. And it's a controversial topic. In fact, it wasn't until just recently that it was considered taboo to do it. The idea is that authorities or some sort of consensus from Earth should be involved in putting the message together. Now, since then, astronomers have had a couple of different meetings. Astronomers, psychologists, scientists have gotten together and discussed this topic. And they've pretty much come up with a set of rules that before messaging should actually occur. But that doesn't prevent the entrepreneurs from doing things. And they have been. There's a surplus dish, I think, in California that was bought and put together for that purpose. The point I think is important is that the Earth has been transmitting signals that are easily detectable at distances using the telescopes that we have here on Earth. And there are things that you could glean from those signals, but not the underlying information. Okay, so probably the most sensitive signals that could be detected and then decoded at long distance and having information in them are things that ham radio operators transmit Morse code at the moon with big antennas and the maximum power they're allowed to use. And those signals can make it out. And so certain shortwave, or I shouldn't say shortwave, but microwave broadcast signals up around a gigahertz and higher can be detected at these distances. And they might represent some of the first things that were decoded, perhaps some Morse code signals. I've been, on another topic, I'll just say very quickly, but I'm also interested in whether or not the early radio telegraph signals could now be out 80 light years out from Earth, because they were basically transmitting a couple of 100 watts every time they closed the key into mile-long wires. So with enough signal processing at a receiver and a lot of aperture and low frequency, and it would of course have to penetrate the ionosphere, which normally doesn't happen, but at times it can come through, they could detect our early telegraph signals. All right, so we might have a shell of thousands of stars around us that have already been potentially able to know that what base 10, that we're using base 10. And we transmit characters, things like that.
Back in the 90s, I was doing some of the SETI at home as well, at my home and at my work, and on that. Since the 90s, right, there's a lot more computers in people's homes, but there's also a lot more compute power in the cloud, AWS, Google, Amazon, all that. Is SETI at home still a useful thing? Are there enough people using their home systems to contribute computes that this is still worthwhile? Maybe there's just a lot of data that needs to be processed.
It is, and I've been to Arecibo and seen the drives that they take out of the machines and ship to Berkeley. Also, the same one at Green Bank. There's a place there where they take the SETI at home data, send it to Berkeley, and then this display that I talked about shows the active signals that are or packets rather that are being sent out. So it is ongoing, and it's been improved a lot. There's been a lot of improvement made to the SETI at home algorithm, and it uses the same concept of the screensaver type of thing that as it started.
It's hard to call it radius. What's our sphere? We have a sphere of how long we've been broadcasting at the speed of light or whatever that's reaching out beyond us. Other civilizations out there or things would have those spheres. How far are we reaching as far as signal goes? Like, how far can we look out from Earth to find something? How far do these telescopes actually look before everything would be sort of diminished and lost in the noise? Like, how far, what kind of reach do we have to find those signals?
Yeah, so it depends on the transmit powers and things, and the size of the transmitting antennas. As far as if we're trying to receive something from them, they would need quite a few large antennas if they were out at 50 or 80 light years distant. The stable signals that have been transmitted from Earth started in the 1930s with the first national broadcast, NBS, national, or the standard frequency of 5 megahertz. That was probably one of the first signals stable enough to be integrated over a long period of time. So we're talking 80 years, right? So 80 years ago, so really the close-in things, when we consider round-trip times, it's not that far. It's only a couple thousand star systems that might be able to do a round trip based on what we've been transmitting. So then you get into the idea of whether or not they could predict that there was a sentient species on the planet that was eventually going to become intelligent enough to transmit, that sort of thing.
But since you mentioned Arecibo, I know it had quite a bit of damage. I believe that big thing in the middle fell during the hurricane, and I'm wondering if it's back up running.
I was in contact with a ham radio operator. Well, he sent a message right after the hurricane. I volunteered to go down there to help out with communications because I'm a ham radio operator, and I do emergency communications. And he said that actually what happened was something did fall into the center, but the center part was not seriously damaged. There was a couple of panels at the bottom that got something that fell from up above, but it didn't cause serious damage. In fact, I think it was back on the air in a week. They had a bunch of volunteers who came out and fixed the panels that were at the bottom of the dish. I think it's in pretty good shape right now. I don't think that the dome, the secondary, the dome that was added to the feed was damaged.
Going back to your statement about the television stations, how does their power output compare to the early defense radar systems that were in use during the Cold War between Russia and the U.S.?
Wow, I don't have the numbers off the top of my head, but the radars are more powerful than television broadcast. I don't know how much, but they are the let's call it the easiest to detect signals as far as especially the planetary radar. So Arecibo has a large transmitter. Last time I was in Arecibo, I wanted to go down to the center of I got a VIP tour, and they said, well, we can't take you to the center of the dish right now because it's transmitting. And when it transmits, it's basically a very dangerous place to be near. But that transmitter is, I believe, still probably the most powerful transmitter on Earth, is the transmitter that's used to reflect signals off Venus and the sun. It's quite amazing. But it's not transmitting all the time like the rotating Earth providing the television carriers, and there's a lot of those all across the planet. Now, digital TV has changed that a little bit because it's spreading the signal out. There's still a small signal there, But there's still a lot of analog that's being transmitted now, and it's been transmitted for a long time in the past.
Have any other participants in SETI found signals that have a high probability of yielding something useful than what you found down in Green Bank?
Not that I know of, although everyone has wow signals, and some of the wow signals have not been discussed, because it's just not proven, not repeated. The idea is to just find out if there is a location in the sky that has a repeating signal, and then get around the RFI problem. And that's why we're doing it the way we're doing it, is that I just have this sort of fear that the longer we continue looking with only one telescope, the longer we're going to be ruling this as RFI and calling it RFI. That's the standard answer. I mean, a lot of people see wow signals all the time, and they just have to say, well, yeah, but we don't know what the military might have up there. Jill Tarter once told me, she said to me, when I told her I see weird pulses from the sky in certain directions, she said, it's your tax dollars at work.
As you know, there's a lot of interest in life in the universe, and there are a lot of wacky things out there, and everybody has an opinion about it. But about a week ago, I saw an article in the paper that said there was an article just published in a scientific journal that said astronomers detected something flying through our solar system that seemed to not follow the laws of physics. And that caught my attention, and I haven't read the article in the scientific journal, but I wonder if you know anything more about that.
I believe it's been classified technically as an interstellar object, which it is alone in that classification. Although it is believed that it is likely a comet, if it is anything. What you're referring to is the fact that it came in. So it is the first object that originated outside the solar system that has come in to the solar system that we've been able to detect. It came in at a very high speed, and based on the best data or look that they got at it, it's very long, about 10 times longer than it is wide. So it's an unusual shape, but it came in very fast, and it seemed to change direction in a way that was not consistent with the way gravity would have, if it was just, affected by the sun's gravity, would have changed. It is still consistent with outgassing. Comets, as they enter in the atmosphere and they get heated up, the liquids inside them, they turn to gas, and they can expel out and actually push it one direction or another. So just because it was moving strange doesn't mean it was something, but it's strange enough that people are really taking a serious look at it.
You say you use two locations to filter out things from, like, what was it, 1,024 miles from Earth. But do you ever find things that you're not supposed to, like, that aren't extraterrestrial?
I see, I believe, cell phones. I've seen clock radios. So I don't know. That's a good question. In fact, eventually a communication system that's very efficient for celestial communication could also be a communication system useful to transmit to the planet Earth. Now, the problem with that is that if the detection of the pulses requires a 40-foot dish and a 60-foot dish, spaced 1,257 miles apart to make them not look like noise, then two things. The transmitter's got to be about 720,000 miles away to have the right Doppler shift. But the second problem is, why would anybody put anything out there that's at a fixed location in the sky, a fixed celestial direction, and then require that people on Earth need 40 to 60-foot dishes to see the pulse? It's only a quarter second long, so there's not much we can do except use a 3.7 hertz bandwidth to detect it. I haven't seen anything that I would claim, or think to be some kind of clandestine satellite. Okay, I mean, I'm not going down that direction right now because it doesn't seem like that kind of RFI exists. I see other RFI that I can explain. It's pretty easy to determine that, based on the characteristics. Not easy, but it's doable.
Looks like your dish is 28 feet, right? And the one is 60, one is 40. And I'm curious, I'm thinking, I don't know anything about satellite communications, but I'm thinking your dish might be less sensitive, and so wouldn't you have to see a signal that's stronger or cleaner or lasts longer?
That's right. Yeah, it would have to be. Now, one of the elements of our system is that we don't measure all the way to the noise. Okay, we have a 12 dB, which is about 15 or so threshold. The signal has to be 15 times higher than the noise. So on my farm, I can run those computers 24/7. I can also store data to a lower signal-to-noise ratio. So if I see pulses that are weaker than the 12 dB threshold, but they happen to fall in the same frequency at the same time as the ones in Greenbank and Colorado, then that's still very significant. But yes, it is less sensitive, and that's a problem. It just has to do with how big an antenna I can build.
I was wondering, what's your plan to keep the snow off?
Oh, that's a great question, because I've had numerous dishes on my farm destroyed from snow. And I was actually trying to come up with ways. I find that if I just hit it every now and then, that the snow will fall through the mesh. But I was at Haswell, Colorado, and we were having a party outside, and there was a guy there. We were under the dish, and there was a fellow there during our party, and he said, I know how to solve your snow problem. The truckers have figured this all out. There's a thing called it's a weight on a motor that rotates. And he went and found an old surplus one and sent it to me. So what I'm planning to do, I've almost got it installed, is to put it on the dish, and then from the house, I just push a button, and it applies 12 volts, and it shakes the whole thing. They put them on the back of trucks that are emptying sand and such, that if they get a little wet, the stuff gets stuck, and then they just shake the whole bottom of the truck with these shakers, I think they call them. There's a shaker. And everything comes out as a result of that. So we'll see what happens. It basically sheds the snow through the mesh. That's the idea. But that's a very serious problem.
So I'm curious, how many of my tax dollars are going to support this?
So none. I volunteer, right? So they don't pay me to go down there. And in addition, all of the equipment that I've installed to improve the 40-foot telescope is all donated. So I donated all the electronics and things over the 2 years that I worked on it. This project is totally radio amateurs and the Deep Space Exploration Society through donations. And all of the equipment that I've been using is all stuff that I just bought, myself. So no, this project has no tax dollars. Now, you may have heard that the government stopped spending money on SETI quite some time ago. It was part of the movie Contact, that whole issue of the politicians didn't like the idea, Golden Fleece Award kind of things. And so right now, NASA doesn't have a active radio SETI project. It was canceled. In fact, that's how, when Jill Tarter left to work in the SETI Institute, she left Ames, and she was doing exactly that. The government doesn't do this anymore, so really, essentially, it's zero tax dollars. It's all donations.
I was in a class and saw a TED Talk. A woman was talking about SETI, and there must be life out there considering the infinity of the universe. But perhaps we shouldn't be disturbed not to be able to communicate, not only all the different varieties of communication that are possible, but consider how long life has existed on this planet. It's an infinitesimal portion of the life of the planet. And then once a life form develops, big enough brain and opposable thumbs are the extraterrestrial equivalent. How long does it take for them to self-destruct?
My home away from home at the Greenbank Observatory is the room that the Drake equation was first proposed by Frank Drake. in the 60s. Okay, and the equation is on the wall, and it's a description of exactly what you're talking about, because the last coefficient in the Drake equation is the lifetime of the civilization, and that has been discussed as a real showstopper, and particularly, we have some knowledge about that possibility.
Yes. Have you ever heard of Stephen Greer and the Disclosure Project? Well, it's a pretty fat book that was put out 20 or 30 years ago with a whole bunch of military people that have disclosed their own experiences in this. And he is presented in front of Congress and so forth. So I think that there's a lot of evidence out there that isn't being talked about here. Also, what about other means of communication? Monroe Institute and Association for Research and Enlightenment, these things have other, telepathic types of communication that people practice and is proven. And remote viewing is another thing that's been done by the military for years, and they have done remote viewing for extraterrestrial objectives as well. So there's an awful lot of other means of communication. I really think that you have to look outside the electromagnetic spectrum.
I think that people should try all sorts of things. This is radio. I do a lot of radio, so I'm quite familiar with that. But no, I can't rule out people studying other things involving psychology and the human brain, how it's working, that sort of thing.
Let's take a look at what's happened on this planet. Let's say the last century. Why do we think that aliens actually maybe want to reach out to us? Maybe it's like the signals you're getting are like, oh, Klaatu, you let the signal out, you're careless here. The Earthlings almost found us.
Right.
Maybe they want to, all couple different civilizations are laughing and watching us and trying to avoid us.
Is anybody an expert in like gamma ray burst detection here? Because I want to ask the question, and I've been thinking about this a bunch, is that after the quiet time, after World War II, where the ham radio operators were no longer allowed to transmit, and conceivably that some of those signals might have been picked up, and then suddenly they stopped, communication all changed, and then there's all these gamma ray bursts in the atmosphere. Okay, what are these people doing? They're a warring species. So if it's possible to detect a gamma ray burst at celestial distances through the atmosphere, now of course the atmosphere attenuates that, it produces secondary particles, but if it's possible to detect a gamma ray burst, maybe they already know that we're dumb enough to blow up nuclear weapons in our atmosphere.
People have kind of mentioned a little bit about some of the technology that we are using. And I like to kind of go back to something Jill Tarter said in terms of, if you go to the ocean and you scoop a cup of water out of the ocean and you look at it and you conclude there are no whales in the ocean, only because of the instrumentation that we have. Do you see any specific technologies that would help in this particular search coming down the pike? Or is there anything that you are looking forward to there being developed?
Yeah, more computers, faster computers, more servers. So the Breakthrough Listen team was able to fund a large increase in the signal processing capability at Green Bank. And so that's always beneficial, is to try for that. The direction that we're going in is to say, well, we need these telescopes that are far apart to be able to rule out RFI, and then maybe more of them. So I keep asking, when I meet amateur radio operators that have some pretty big dishes, I say, maybe you can participate in this. Eventually, the idea that there would be a pulse on 3 telescopes at the same time, that happens about once every million days. So about 13 hours it's happening between the Haswell and the Green Bank, the 40-foot and the 60-foot. If there's a pulse that's significant outside the noise in New Hampshire, then yeah, that's a pretty rare event. And it may not take very much to just say, yeah, this is not noise. So there's already some indications in these pulses that the pulses are not due to noise, due to this, 3 in 10,000 event that I mentioned. By the way, that's a lot of these pulses are due to noise. Okay, so there should be about 14 of them roughly if it's due to, caused by noise. So only perhaps a few of those are actually even potentially extraterrestrial based on the statistics. The problem is that some of those pulses have these associated pulses that are very rare, where there's two tones really close together and then there's a bunch of them. And I'm looking at those in the data and I'm going, why are these two tones really close together here, 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 and here in the same time period that the two telescopes detected a simultaneous pulse far apart? In some cases, at the exact same time, there's something else that shows up in the same quarter second. Those things are hard to explain due to noise and even due to RFI. But I think that a system that does something like this, this is the reason I go down this road, because I think it might be better than using single telescopes.
So just to continue on the thought here, because I never heard that quote by Jill Tarter, you said, you can certainly scoop in a cup of ocean water and say there's no whale in the oceans, but I would just saying you have the wrong sample set. So the other aspect would be not as much as the improvement in the technology, is there a way of improving the sampling to get maybe better results, different results? Right, yeah, definitely. If we knew where to look, for example, that would help a bunch. Yeah. Because, let's use an example. Let's just say that some of these pulses I wanted to follow up. Well, I could go to the Breakthrough Listen team and say, I've got these 3 locations that I'd like to follow up because we've seen 2 pulses. Maybe we see a third one, the same pointing direction. I say, I'd like to have some time on it. Well, the problem with that is, just to give you an idea, that cup issue, the water in the cup issue is a really big deal, because if I went to the big telescope, the Green Bank telescope, and got time on it, the beam width on that thing is only 1/100th of the sky compared to the antennas we used. So I don't know. I'd have to have 500 minutes on that telescope. We only see these pulses about every once or so when the beam is pointing in that direction. So they could be spaced by 5 minutes, but to see it, I'd have to scan the sky for 500 minutes. I can't get that much time on the Green Bank telescope.
How often do you feel frustrated by natural phenomenon giving you false positives?
So I don't get frustrated, all right? Because, again, I'm in this for the journey, not the destination. I love building this stuff and coding the software and solving problems involving communications. That's what I've been doing since I was a kid. And so when something goes wrong, I'm kind of happy, because it means I'm making progress. I discovered something that was wrong, and I just love it when somebody says, "Yeah, and this thing isn't working right." Okay, well then we got to figure out what's wrong and fix it. So no, in fact, I think some of the people I work with are sometimes annoyed by that, but I don't get worked up over it at all. Not a problem. Yeah, that's another thing is that I'm. This is in the observation phase, and right now, technically, we're not even in the experiment phase yet, because the hypothesis has been proposed, the method is being proposed, is being put together, and we're going to have to run a lot more tests on this before we, can say anything about it. But the reason I talk about it is because I just hope that other people will sort of pursue something similar to it, and it's also, something that can put a little hope in our thoughts, is that as we go on, we kind of all wish that, maybe there's work going on to try to find these signals.
All right, well, I had a chance to talk to Skip a little bit, and I'm going to ask him and Johnny to comment on, I guess there's physics involved. The sociological impact of radio telescopes is an interesting thing that I never thought of before. So can you speak to the concept and implementation of quiet zones, and maybe make your way to the sensitives from there?
Right. Yeah, we had a great conversation on this. It turns out where I work, it's called the National Radio Quiet Zone. It's 13,000 square miles that by U.S. law, international law, and West Virginia state law, transmissions are not allowed. Now, certain transmissions are allowed, like public safety. But it's very difficult to put a tower up. That whole area doesn't have towers on the mountaintops because they interfere with the telescopes. It's perfect for radio astronomy. The idea is also very useful for people who believe to be sensitive to radio frequency energy. Okay, so then they're called sensitives. That's the name that they have acquired, which means that they can sense and are affected in their health by the radiation. The wireless companies don't like to use the term radiation, so I shouldn't say it that way, but the transmissions from signals. So the idea is that they go to Green Bank, and there's a bunch of them who live there. And there, you can see them on the internet, the web. I think YouTube has some documentaries they've made about the sensitives who live there. And they are, it's a very interesting problem. They believe what they've left their families in some cases. I think there's 3 commercial pilots who have moved there because they are upset with the communication signals bother them, and they want to live there.
So, other questions?
So these sensitive people apparently have Wi-Fi in their house because they're using computers. Why aren't they sensitive to the Wi-Fi signal?
So the sensitives do not want anything around them. In fact, to some extent, the AC power becomes an issue. But the idea that they would have anything that transmits is strictly taboo to the sensitives. And, it's, or, they would use a wired Ethernet, I would guess, if they, get on the internet, yeah. In the actual area around where the telescope is, outside of the close-in telescope zone, intentional radiators are not permitted. Anytime somebody comes in with a Wi-Fi device, it's taboo, and there's signs in various places, even on the road, way out on the road, it explains that you're entering a quiet zone. Cell phones don't work because there's no towers, there's no service. There are people who might find that out, okay? The telescope is very sensitive, and it's very high up. That's 450 feet up at the top of the telescope where the feed is, and it's cooled. So it's very, very sensitive, and it's looking, potentially a little bit to the side. There's a little bit of side lobe energy, and it uses all frequencies. So it measures in the 2.4 gigahertz band. There's a truck that it looks like a porcupine. It's got so many antennas on it. And it drives around, and it'll go right into the town. And if there's a signal that's being transmitted, they'll go track it down and try to get somebody to do something a little bit different.
I don't want to get too hung up on the sensitives, but is there empirical evidence or maybe studies taken to show it's not just a suggestive or placebo effect at all?
We've been thinking about that. Obviously, if there's a detection mechanism that human beings have, astronomers would be very interested in that, right? Because that means there's a new kind of detector. Now, I've heard some sensitives claim that they think the signals are coming from celestial distances that they're detecting. Okay, not just nearby transmitters, but they think they can detect far away things too. So that makes astronomers even more interested. As far as a study, we have, there are people at Green Bank who have proposed doing a study of the sensitives at Green Bank. And for various reasons, it's a kind of a sensitive topic. It's kind of difficult. I don't think it's making a lot of progress, but I don't know the latest on it. But there are people who are interested in doing that.
So quiet zones are not limited to West Virginia, right? So you were telling me there's one in New Hampshire?
Yeah, so there's an antenna that has a lot of 85-foot dishes all over the United States. It's a very long baseline array, VLBA, and that has one of its elements in Hancock. All right, so it turns out the FCC has a circle, 20-mile radius around Hancock, around where that antenna is, and they limit tower licensing in that area. So I fortunately happen to live right on the edge of that 20-mile. Not strictly coincidence. I didn't know I was going to be there when I went there.
Please join me in thanking our panelists. thanks for coming, and thanks again to our panel.